Okay, so hopefully I'm sharing my screen here. This is something, this is a file that I just posted to the reading section of Moodle called Groundwater Regions USA. And it breaks down, it's a United States Geological Survey report that breaks down the different hydrogeologic provinces of the US. And so what I'm going to do is kind of hit the highlights here and then ask you guys to skim through the uh, the different parts of it that are spelled out in more detail chapter by chapter. So you can see the United States here. We're not going to focus on. We're only going to focus on the lower 48, but this is a way of sort of breaking down in by geologic characteristics each of the different zones in the U.S. according to this, right? So, for example, let's start down here. Southeastern coastal plain. This whole area, which is Florida, is, if you've ever been to Florida, seen photographs of Florida, it's pretty low lying, it's pretty flat. A lot of the rock that was deposited um, that makes up the uppermost portions of the rock in Florida was deposited as sea levels rose and fell over previous millennia, hundreds of thousands of years, millions of years. And in the warm and shallow tropical or subtropical waters of this part of the world, limestones were deposited. So there's lots of limestone down here. And so what would we expect? Well, we'd expect lots of karst, right? Lots of sinkholes and caves. And the aquifers we'd expect to be really good. One of the challenges, though, of course, is that it's low lying and it's surrounded by salt water. So there's an issue there of the intrusion of salt water as you pump fresh water down. So imagine that you have fresh water at a certain elevation, let's say a meter above sea level. And as you begin to pump that water down, if you begin to overdraft it, that's got to be replaced by water from somewhere else. And so the salt water, the ocean water will come in, and that can conceivably contaminate your drinking water supply. Here, let's jump over here to the Columbia Lava Plateau. So this is an area of extensive volcanic deposits, lavas that are hundreds and hundreds and hundreds of feet thick. The lavas, when they erupt, they not only form layer by layer, but they form different kinds of materials, um, some of which include lava tubes, which are like literally like caves, which can have very high capacity for storing water. But anyway, the main point of the area, if you're in the Pacific Northwest, one of the things you should be thinking about is lava. There's a lot of volcanic activity up here. There's Yellowstone, which is a big, essentially volcano. There are the Cascade Mountains like Mount St. Helens and Mount Rainier, which are volcanic. And there's just lots and lots of volcanic activity up here. So there's lots of lava. In general, igneous rocks like lava have pretty low primary porosity, meaning there's not a lot of original space between minerals, but they fracture and create joints and fractures and faults pretty easily. And that's where most of the water is stored. We go down here to this area, these alluvial basins. This is a part of the world called the Basin and Range. The Basin and Range is Nevada and big chunks of Arizona and northwest New Mexico, or western New Mexico, and so forth, and parts of Utah. And basically, what happened here is the crust got stretched to the east and the west, and as a result, you get those down-dropped basins, like I was sketching for you in the previous lecture. And as the rocks drop down, the low-lying areas fill in with sediment. So those alluvial basins, which are between the mountains, are very high in porosity and are capable of storing a huge amount of water. The downside, of course, is that this is one of the driest places in the lower 48. And basically the reason being that you have the big Sierra Nevada mountain range over here that blocks moisture coming in off the Pacific. And so there's just not a lot of rainfall there. So there's a lot of capacity for storing groundwater, but there's not as much groundwater as could be there. Nonetheless, there's a lot of groundwater because these alluvial basins are quite deep. Over here, we have the Colorado Plateau. This is the area that is like the Coyote and Roadrunner cartoons. We have these relatively flat-lying rocks. that have been uplifted, and rivers have kind of incised down into them. It's a lot of sandstones and limestones, and in general, the primary porosity and the secondary porosity are both pretty high. There's a lot of faults and fractures, but the rocks themselves are pretty good at holding water. Uh, Across the high plains here, there's something called the High Plains Aquifer. This includes the Ogallala Aquifer, and these are sands and gravels and things that were shed off of the Rocky Mountains, which run right through here as the Rocky Mountains rose. So the rivers and streams that formed from on the east side of the Rocky Mountains were carrying all this sediment out here into the plains and depositing it out here tens of millions of years ago. And those gravels are still largely unconsolidated or poorly consolidated. So there's still a lot of space between them. And this is a incredibly valuable resource for the farmers that are out there. One of the things to know is that, let's see if I can figure it out. This is Missouri, state of Missouri right here. And I don't know how well you know your geography or how much time you've spent driving around, but if you're over here in Indiana and Illinois and Tennessee and so forth in Missouri, it's really humid. There are lots of trees, lots of humidity. But as you move west, you get basically to the Missouri-Kansas line or Missouri-Oklahoma line right in here. And things start to change really quickly. It starts to get drier really fast. And there's a reason for that. And that is that the moisture that we get in the middle and middle United States and southeast United States comes largely off of the Gulf of Mexico. So there's a lot of evaporation of water up here, and it gets transported up like this and falls as rain and snow. Well, the prevailing wind direction coming across the plains is from west to east. And so that moisture has a hard time making it very far to the west. It kind of gets stuck over in here. And as a result, as you move across Missouri and into Kansas, it just gets drier and drier and drier and drier. And that's amplified by the blocking effect of the Rockies and the Sierra Nevada that stop any moisture coming in off the Pacific. Anyway, so if you're out here in western Kansas or eastern Colorado or in western Oklahoma or Nebraska, it's really helpful to have a groundwater source for agriculture. And this alluvial aquifer, the High Plains and the Ogallala aquifers, have been tapped pretty extensively. In some cases, water levels have fallen over 100 feet because of pumping since the early part of the 20th century. When you get up here into the areas around Iowa and Illinois, Indiana, northern Missouri, and that sort of thing, what you have is a lot of pretty boring geology. It's rocks that were deposited 500 million years ago, flat-lying limestones and sandstones and shales and those sorts of things, mostly sandstones and limestones, that were deposited back when sea levels were much, much higher. And quite frankly, North America was a little bit lower back during this time period called the Cambrian, the Ordovician, the Silurian, but about 500 million years ago. And nothing really geologically interesting has happened to these rocks in all that time. There's a tectonic plate boundaries way out here in the Atlantic, or for a while here on the East Coast that form the Appalachian Mountains. There have been tectonic plate activity over here on the west, forming these volcanoes or forming the Rocky Mountains. But here in the middle of the North American tectonic plate, it's just been boring. Nothing's happened. So those rocks have stayed flatline. The one thing that has happened that's kind of interesting is that glaciers have come down repeatedly and have smeared glacial till over the top of these layers. So the glacial till, as you may remember, generally is very low hydraulic conductivity. But once you get down through that, a few tens of feet or hundreds of feet, you get into what are often very, very productive aquifers of limestones and sandstones. It's what Mount Vernon uses. They drill down to something called the St. Peter sandstone and this Ordovician limestone aquifer, which is 500-800 feet down. Let's see. If you get over here to the East Coast, you have a lot of mountains, right? You've got the Appalachians that are running through here. The Appalachians, depending on what sector you're in, have some sedimentary rocks, but a lot of them are underlain by these crystalline rocks, these igneous and metamorphic rocks that in general don't have great porosity. But because this is a mountain range, the rocks are fractured all to hell. And that's where a lot of the water resides. It's able to be transmitted very, very quickly through those fractures. And there are a lot of fractures, so it stores a lot of water. Likewise, when you get up here into upstate New York and New Hampshire and Vermont and Maine and Connecticut, you get into these not so much mountainous regions. Well, I guess Vermont has plenty of mountains, but they're not. Well, no, it's still the Appalachians. Well, nonetheless, it's a lot of a lot of metamorphic rocks like slates, marbles, um, and granites and other things, which again, generally pretty low hydraulic conductivity, except for the fact that they're so fractured. The downside, of course, is if you're going to drill a well, it's much harder to drill through something like granite than it is through limestone, because limestone is so soft, and the granite is much harder to deal with. Let's see. I think is there a map in here? Those are the alluvial. This is a map again from the groundwater regions of the USA that I posted to posted to Moodle for you to look at. This is a really coarse sketch of the major river systems across the United States, and it's in these valleys that there is so much groundwater potential, because the rivers are relatively small compared to the river valleys that they flow through, which are again filled with all sorts of gravels and sands and that sort of thing. And there's sort of a schematic of a alluvial valley deposit. But I wanted to show you, I don't know if it's in here. Let's see if it's in here. There's a map I thought of cave locations around the US. Maybe it's not in here. Well, anyway, it's not. Let's see if I can, well, anyway. So there are limestones all over the US, and it's those caves that do such a good job of, and karst features that do such a good job of storing and transmitting water. Okay, so that's the end.